But aloha, everyone, and mahalo for joining us today for the Know Your Ocean speaker series. So excited to jump in to today. We will talk a little bit more about the topic, but as you guys know, it's going to be going over the 10-year report from Hui o Ola's water quality data. So really excited for that. But for those of you who don't know me, since this is actually my first Know Your Ocean speaker series since joining the organization, my name is Kailea, and I'm the new Communications and Development Director at Maui Nui Marine Resource Council. For those of you who may be joining us for the first time or aren't familiar with our organization, we are a local 501c3 nonprofit dedicated to protecting and restoring marine ecosystems of Maui Nui from Mauka, the mountain, to Makai, the ocean. And that connection, Mauka to Makai, is really at the heart of everything we do because what happens on the land is so deeply connected to what happens in our ocean. And as you'll see actually on this next slide, that mountain to sea approach is reflected across all of our programs. Here are just a few main ones that we're currently focusing on, but you can see in the images as well. Like we really start on the land through our RFL, reef friendly landscaping training and certification, where we help homeowners and landscapers learn about how their landscaping can be benefiting our reefs. And then all the way down to the bottom of the ocean, where we just established Maui's first CBCRA, which stands for Community-Based Coral Restoration Area in Kihei, where we're able to reattach broken corals onto the reef to help them thrive again. So, like I said, we're really looking at that whole system when it comes to protecting our ocean environment. But another really huge part of what we do is the science behind everything. So, um, that's where the Know Your Ocean Speaker series really comes into it. It's making this crucial information more accessible so our community can have a better understanding of what's happening in the ocean around us and how we can play a role in protecting it. So if you are interested, we'll drop a link for our newsletter, Reef and Brief, where you can get updates about more um, speaker series like this, other work that we're doing in the community, as well as like volunteer opportunities. So it's a good way to kind of just keep in touch with what we're doing. And like I said, we'll put a link in the chat just to make it really easy. And then on the next slide, we do, just before we get started, want to give a special mahalo to the County of Maui Environmental Protection and Sustainability. The speaker series is made possible through their funding, and we're incredibly grateful for their support in making these educational conversations available for our community. So mahalo nui loa. And then just a couple, few housekeeping notes that will be important as we get started is this is a recorded session, so you can see it and view it again on YouTube. And then we will have a live Q&A at the end of the talk. It'll be about 10 minutes. So feel free to use the Q&A feature button. And throughout, if you have questions come up, feel free to put them in, and then we'll work on getting through as many as possible at the end of our session today. So, with all that said, really excited to dive into today's topic where we look at something that is so important to all of us, especially those of us who love Maui's oceans, and that is the health and water quality of our nearshore waters. So, for the past decade, Hui o Ola and its dedicated community of scientists and volunteers have been collecting and analyzing coastal water samples. And now, with this long-term monitoring, we're able to reveal patterns, identify ongoing challenges, and show where attention and action may be needed. So, tonight we'll hear about that decade of monitoring, what it's revealed, and why this information is so important for the future of Maui's coastal ecosystems. And to guide us through the conversation, I'm very excited to introduce Liz, who is the director of Hui o Ola. She truly is the heart of the organization and oversees the programs, monitoring operations, data collection, volunteer and team coordination, and helps ensure that the high quality standards behind this important work continue to be met. So we're so grateful to have her here tonight to share what 10 years of this incredible community-based monitoring has taught us. So without further ado, Liz, I will turn it over to you.
Mahalo, Kailea. Give me just a second as I share my screen and get it all situated. Okay. Thanks for your patience. Okay, so can you see this? Can you see my slide?
Yes.
Hooray. Okay, so let me get a tiny bit bigger and see if that makes a difference. Okay. All right, ready to go. Aloha mai kako. Thank you all for joining us tonight. My name is Liz Yannell, and I'm the director at Huioka Viola. And we also have Dr. Kim Polinsky here with us tonight. And Kim is our lead scientist at Huioka Viola, but I feel like that is a very insufficient title for Kim. She's involved in lots of important research and networking around water quality. She's been a part of Huioka Viola since the very beginning of the program and is the lead water scientist of Hawaii and Palmyra at the Nature Conservancy, one of our main partners. She'll turn her camera on at the end to be a part of our Q&A, as Kailea mentioned. Okay, so the overview of what we'll be talking about tonight, just starting off with coral reefs and water quality, the importance, who we are at Huioka Viola, things you can do, and then dive into our data, talking about chronic hotspots and emerging trends that we have really recently been able to uncover with our 10 years of data. And I just have to start by saying we won't have time tonight to talk about partnerships, management recommendations, or the work being done already to address the concerning areas we've identified with our data. That might have to be a different webinar, but tonight is really just about our data and our findings. Then we'll also discuss ways to learn more about water quality in Hawaii and Maui, Maui Nui. And again, questions and answers at the end. Okay, so the importance of coral reefs. The Kumulipo or Hawaiian creation chant tells us that the ko'a, the coral polyp, was the very first organism created. And it's the base of every life form on Earth. We are interconnected. We depend on our reefs to feed our families, for our tourism and our economy, to sustain our traditions and personal enjoyment, and for the shoreline protection during storms and large swells. We also depend on our coral reefs to sustain, truthfully, it's like to sustain the future of the places and the people we love. And in turn, coral depend on us to thrive. Healthy coral reef ecosystems need healthy water. They need clear water, a nice current, low input of nutrients, amongst, comfortable temperature, the right acidification and the pH. Yeah, it's really, they're kind of, like the Goldilocks. And these healthy coral reef ecosystems, they require healthy water, as I mentioned. But healthy water, I feel like it's just a nice reminder that healthy water requires healthy communities, communities that come together, communities that give back, communities with a sense of connection to their home and practice activism and informed decision-making. Because in the end, we can only protect what we measure. We can't protect what we don't understand. We can only manage what we've collected data on. Coral reefs are fragile and susceptible to even the slightest changes in ocean parameters. So measuring coastal water really helps us understand the dynamics in an area so we can better protect the reef ecosystems from harm and improve their resiliency against other stressors. Oh. Okay, there we go, sorry. So who we are, a little bit of who we are. Huioka Viola means the association of the living waters or the thriving waters. We began on Maui in June 2016 as a community science initiative to address a gap in local coastal water quality data. And from the beginning, our goal wasn't just to collect data, it was to collect trusted and quality assured data that protects our waters and drives positive change. Our founding partners and still main working partners include the logos you see at the bottom, Maui Nui Marine Resource Council, our hosts tonight, whoop, whoop, the Nature Conservancy, including Dr. Kim Felinski, that will pop on later, and the West Maui Ridge to Reef Initiative. So 10 years later, we've expanded to collect samples across Maui Nui and have supported sister programs to launch across Hawaii. And what makes our program unique is that we've spent a decade earning the trust that comes from rigorous science, dedicated volunteers, consistency, partnership, and teamwork. Oh, and we've collected in all this time over 5,500 samples. So the mission of Hui o ka Waiʻola is to advance understanding and protection of Maui Nui's coastal water quality through science, community action, and advocacy. So things you can do. I thought I might start with this before we jump into data. Don't give up hope. No task is too big when done together by all. Many hands make light work. As Dr. Sylvia Earle said, saving the ocean is a team sport, so we can all offer our part here. We can all do something. And I love that Hui o ka Waiʻola is a part of the community and allows us all to get involved in ways that truly matter. And donations truly matter. They really help us. Your business, or your organization can adopt a site. It costs $6,000 per site per year. And right now we have 47 sites. So, we are looking for to fill our budget every year. And our team is really dedicated to figure out Maui's ocean chemistry story and find solutions. Your donations really do make a difference for us. And additionally, another new campaign we have is to celebrate our 10 years of data. We are launching the campaign that you could donate $10 or more to help us celebrate this big milestone of quality assured data, 10 years. As many of you know, we lost our West Maui lab in the Lahaina wildfires of 2023, and we're still looking for a more permanent lab space, like a small kitchen space with running water, or we can get pretty creative. We dream of potentially having like a container that we could fit to work for us, like a trailer space that could become our more permanent lab that has water and electric hookup. But yes, your donations in this campaign can help us afford rent or a container space to make our work easier. I do want to take a moment to thank NOAA at the Hawaiian Island Humpback Whale Sanctuary and Kihei for supporting us with our Kihei lab I think since the beginning of the program. And since the fires, we have other people to thank, including Lahaina Luna, 808 Jiu-Jitsu, Department of Aquatic Resources, or Division of Aquatic Resources for lending us temporary lab space since we still haven't found something permanent. And upcoming will be in the Pacific Whale Foundation classroom in Ma'alaya for our West Maui lab space until the end of this year. So yeah, if you have ideas, we welcome all ideas. We welcome all donations to help make our work easier and do things in the lab that we need to do for our field work. Let's see. Oh, and you can volunteer with us. I didn't want to forget to mention that we're particularly looking for a couple new volunteers for our South Maui team, Tuesday and Wednesday teams. You can submit a volunteer application on our website. You could follow us on Instagram or Facebook. We're at Hui o ka Waiʻola. You can also help us share our data and report. And lastly, we are excited you can join us for our Flatbread Community Tuesday Pizza Bake on Tuesday, September 8th from 5 to 9 p.m. And so for every large pizza that's sold, even takeout, they donate $3 to us. And every small pizza, they donate $1.50. So eat good pizza and help us raise more money. Okay, so what we do, we have 13 parameters. As I mentioned, 47 active sites. We sample along Leeward Maui and the Molokai South Shore. We have 8 volunteer teams, and all of our data are made publicly available. We publish our data in multiple places and update it quarterly as All of our data has gone through the quality assurance process with our QA officers, and we receive our nutrient data back from the lab at UH Manoa. Okay, so our physical parameters include things that you see below: pH, dissolved oxygen, temperature, salinity, and turbidity. And to explain a little bit more about turbidity, because it's one that many people aren't as familiar with. Turbidity is caused by particles suspended or dissolved in water that scatter light, making the water appear more cloudy or murky. And just to give you an idea about how turbidity affects visibility, here are 4 photos of Dana Reed and Bill Rathman that they took at Kapalua Bay many years ago. And so you can see on the left, turbidity is at 1.14, and on the right, it's much lower at 0.31. And it's not that huge of a change in turbidity, but it makes a big difference in our visibility and being able to differentiate, is that my friend snorkeling? Is that a shark? What am I seeing? Once you're above 1 NTU, it becomes more difficult to see your friend snorkeling. And I also just want to say that when we find high turbidity or a brown water event, it often indicates that there are issues Mauka within the watershed. We'll probably touch on that a little bit more as we keep going. So it's really important to understand and know the cause of high turbidity at sites so we can appropriately address them. So high turbidity levels can be driven by stream inputs of sediment or coastal erosion or natural resuspension of sediment from either of those sources with wave action and swells. And in many cases, it can be a combination of all of these drivers. And here are our chemical parameters, including organic and inorganic nutrients. And understanding the balance in our waters of these help us pinpoint upslope areas that may need to be addressed. I want to clarify that it is normal and healthy to find these nutrients in our coastal ecosystem. So as long as they're not in excess, corals are happy. As I mentioned before, they're like the Goldilocks. And I think of our chemical parameters as indicators that really help us get the ocean chemistry story of a site at that particular moment of sampling. And unlike turbidity, the sources of nutrients can be harder to trace, but some examples include high levels of nitrates can point us to wastewater and or agricultural influences, whereas high silicates, levels of high silicates can point us and indicate that there's a lot of groundwater entering in the coastal waters there at our sample site. And I also want to point out, on Molokai only, we also test for bacteria. On Maui, we lean on Surfrider's Blue Water Task Force data, where they collect Enterococcus, and that data set complements ours. So we're very grateful for that. And also, I've mentioned all the things that we do test for every 3 weeks in our normal sampling, but we don't test for pharmaceuticals or pesticides, personal care products, or other chemicals of concerns. But we do always pay attention when other people study those things and report about them. Okay, so I hope you're ready for data now. Here we have our graph illustrating the geomeans of turbidity, or water clarity, at all of our sites from 2016 to 2025, going from Honolulu Bay Marine Reserve all the way in the north of the leeward coast to a Hi'ikina'u area, natural area reserve in the south. And the data we collected also from Lanai from 2023 to 2024. So first, I'd like to just point out the black vertical lines. Hang on just a second. I'm moving my Zoom picture so I can make sure I'm seeing everything right. Okay. So the black vertical lines, which give the distinction between West Maui, South Maui, and Lanai. And the range here is from 0 to about 18 NTU. NTU standing for nephelometric turbidity units, which is just the measurement that we use to talk about high or low turbidity values, with high being more brown water or murky water. And I also want to point out the Hawaii Department of Health Clean Ocean Branch state standards for turbidity in ideal coastal waters. So the red dashed line, it is set at 0.2 NTU for the clarity of our coastal waters. So yeah, that's a lot to say about that. But I also just want to explain that a geomean, as I mentioned, these are all our geomeans. So a geomean is an average that indicates a central tendency. And using geomeans is consistent with the Department of Health protocols. And they're useful to us because our goal is to characterize generally what a site is like. So geomeans don't skew the trend lines when there are outliers in the data. And I also thought I'd point out that with most of these geomeans, they represent hundreds of data points. So now I also just want to point out the two peaks in this figure that are labeled, Ukumehame on the west side and Waipuilani on the south side. So these are two of our chronic hotspots that we'll explore tonight. Both sites are largely affected by coastal erosion, but runoff and resuspension are also drivers. And in the case of Waipuilani, groundwater and silicates are also a driver, which we'll get to later. But another big takeaway I want to share with turbidity as we looked at our data this year is that in general, we've noticed that reefs, pretty much cannot sustain turbidity with a geomean that's greater than 5 NTU for an extended period of time. So it's one thing when sediment flushes into a site and turbidity is high for days or a week, but it then circulates out. But when turbidity becomes chronic at 5 NTU or higher, we often see with our partners that do reef surveys like MNMRC and TNC, we often see a correlation of degraded or dead reefs. So of course, every microzone is different, and we're continuing to understand the resiliency of certain reefs and certain species of coral. But sadly, of the 51 sites that we've monitored over time, we have 15 sites that have this concerning above 5 NTU geomean. So this means that 34% of the reefs just outside from our sample sites are struggling, degraded, or already dead. So this is our call to action. We can come together on our island and prioritize healthy watershed systems and the health of our ocean ecosystems. And we can use our data to make that action. Okay, so first one, Ukumehame. This is my husband's favorite surf spot. It's really our family's favorite surf spot. It's the first place I ever surfed on Maui. And over the last 15 years, as sea level rise becomes more evident, we're seeing the ocean reclaim the beach, the picnic tables, the parking lot. I mean, you can see in this picture, that parking lot is just going slowly into the ocean. And this is what the time series of our data collection looks like here since 2016. So this is a zoom in of our data from this site over time. And you see the big gap. So we had to pause Ukumehame for funding reasons in 2020 during the pandemic. That's a little call to funding. But concern grew at this site, and funding was secured to begin testing again in summer of 2023. And that was actually Kim Flinsky that had the mission and was always advocating for this area and really pushed to find funding to reestablish monitoring here at Ukumehame. So we have seen that turbidity has worsened here with clear seasonal peaks due to stream input and swell action. And, as I mentioned already, Ukumehame also has a serious erosion issue. So the geomean for turbidity here at Ukumehame is 9.9. So that is above that 5 NTU. It is 50 times higher than the state standard for coastal waters. And this is just another photo to show you the effects of coastal erosion. Look at these picnic tables. They're struggling, as well as the corals. In addition to erosion, Ukumehame is also challenged by stream input as a turbidity driver. As you can see, that's the Ukumehame stream that flows often and sometimes really brings out these plumes of brown water. And then, of course, swell and wave energy causes resuspension. And this area, Ukumehame and the Olowalu area, are really just so important. Many of you know that the Olowalu Reef is considered the mother reef that spawns new coral growth around Maui Nui. So this area is just really, really worth rallying for. Okay, so next, I'd like to highlight South Maui and our chronic turbidity hotspot, Waipuilani. It really sticks out on this bar graph. It's, very noticeable. So this is the time series of our data collection at Waipuilani since 2016. And you can see, it's lots of peaks, lots of brown water, well above that red dotted line. The geo mean at Waipuilani is 17.6 NTU, so it's quite a bit higher than Ukumehame, 88 times higher than the state standard. Commonalities between these two sites involve coastal erosion, as you can see in this photo to the right, intense sediment input from upcountry rains and flooding. And furthermore, Waipuilani is also a shallow area, making it more challenging for sediment to flush out and get carried away by currents. Sorry. Okay. An interesting thing is that occasionally we're seeing milky water in this area. Like this photo looks nice and clear and beautiful. If I just go back a slide, you can see brown water. There's kind of this milkier, whiter look. Yeah, we've been very curious about that, especially because turbidity has been so consistently high here. And we've realized that this milky water is influencing our turbidity readings even on days that aren't brown. So we've also noticed in our data that silicates are very high here compared to other sites. And from a few slides ago, we spoke about high silicates from our nutrient samples being an indicator of groundwater input. So this is an interesting thing to us because we're seeing other nutrients like nitrates going down over time here. So what we think that we're seeing are silicates and suspended mineral particles here at Waipuilani, not brown water consistently or biologically driven impairments. We're just seeing mineral particles, silicates, and that there's also the issue of resuspension, as I mentioned, not just because the waters are shallow, but because wind really picks up here a lot, and we do get some wave action. And there's a lot to unpack at Waipuilani, but for time's sake, I'm just moving on. Okay, so for more data, I want to talk about the emerging trends that we're seeing. So with all the data we've collected, the story is not just about averages, geomeans, but it's also what sites have dramatically changed since we began monitoring. And the story here in this figure is what we're seeing evolve. So this rate of change bar graph is a way to show how much something has increased or decreased between 2 points in time. And this is a brand new figure that Kim created for us for this report. I'm sorry, for this presentation, but it's not in our report. So if you want to look at it more closely, you'll just have to contact us. You can do that on our website. But the most important thing that I want to share is the zero line. So bars that are above the zero line, the measurement has increased. Bars below the zero, the measurement has decreased. Bars at zero equal no change. The taller the bar, the larger of the percentage change. And these are all of our sites, including the data we've collected since the beginning. So many of our West Maui long-term sites are getting better in terms of turbidity, but some are getting worse. And the standout biggest takeaway is that we're seeing turbidity in North Kihei worsening and rapidly increasing each year since 2022. So turbidity up. And this devastating photo of Kalepalepo, where our Kihei lab is. So here's our time series at Kihei Canoe Club. This site has been impacted the most. And as we mentioned in our presentation 2 years ago with Know Your Oceans and MNMRC, we just started to see this with our last report, with our last presentation. And then sadly, it's been getting worse since then. And these are actual data points. And you can notice how the peaks are getting higher over time, so much higher. The turbidity geomean is 16.5 NTU, which is 83 times higher than the state standard. And it's had a rate of change 30% increase. So the issue with North Kihei and specifically Kihei Canoe Club are issues Mauka, issues upcountry. It's this trifecta, it's this three-part that's just really like triple whammy, right? Like droughts, fires, and the explosion of deer population. It's really changed how much sediment ends up flowing down and accumulating in our gulches and then washing into our waters. And sometimes it's really fine sediment that doesn't carry away easily. And this photo was taken earlier this year, March 2026, after the Kona Low system that devastated North Kihei. This is just turning the other way from the beach at the same site. Yeah, that Kona Low that devastated not just this area, but many other parts of Hawaii. Okay, so now nutrients, talking about our nitrates. So this bar graph shows our nitrate geomeans across all sites. In general, nitrates are more of a concern amongst our South Maui sites due to legacy agriculture and when crops phased out. Sugarcane was in production within the North Kihei watersheds just until 2016. But the effects of agricultural production in West Maui has been working out of the groundwater system for decades. Cove Park really stands out on this graph. Yeah, the Cove Park, chronic hotspot for nutrients. There are a lot of cesspools in the coastal area that discharge raw, untreated sewage into the ground and sometimes very quickly makes its way out into the waters at Cove Park. Injection wells, additionally, from the Kihei Wastewater Reclamation Facility, it's another influence. It pumps 2 to 4 million gallons of discharge into the ocean each day, which is treated water, but it's still high in nitrates. So yeah, just pointing out the red dotted line down at the bottom, all the peaks that you're seeing. The geomean at Cove Park for nitrates is 321 milligrams per liter. That's 100 times higher than the state standards. So there's so much I could say. If you're interested in learning more about Cove Park, you can tune in to the recording from our last Know Your Ocean webinar from 2 years ago. It's on YouTube and or read our report. And what's concerning about Cove Park is what this potentially means for all the surfers that like to go out at Cove Park, you know, all the visiting people that surf for the first time there, and of course, what these high nitrates can mean for nearby coral reefs. Okay, but to end on a high note, if you remember that nitrates are looking low across West Maui, like at this site, Oneloa, one of our bright spots that's always low and in nitrates and turbidity and just gorgeous and pristine on the west side. It's also exciting to say that nitrates are dropping. So here's another rate of change for our nitrates. So even Cove Park has a 1% decrease. And the nitrate story generally here, it's generally showing that the influence of plantation agriculture is diminishing with time and exiting out of our groundwater system that deposits into our coastal waters, as I was mentioning before. And there's still impacts of wastewater persisting in concentrated areas, in Cove Park, as I mentioned, cesspools influencing ulua. And there are just places that we're watching in North Kihei as we see agricultural lands, sugar lands transition into diversified agriculture. We are seeing some upticks, but we're also very happy that in general, nitrates are lowering at many of our sites. And I knew that I wouldn't have time to talk about this other new finding, but we've also noticed that salinity has increased across most of our Leeward Maui sites. So if you're interested in this, please refer to our report. check out page 12 to read more. We have a whole page talking about it and showing some of our figures. So wrapping up, our mission is to turn our data into action. Continuous monitoring allows us to capture trends, identify hotspots, observe changes in water quality, and work with partners to identify actionable solutions at scale, solutions that work on Maui, make a greater impact. And we can also present our data to support policymaking and best management practices and support other scientists with other research that is complementary to ours. So this is a picture of our report. And this talk tonight was really like the movie trailer for The Real Thing, for the featured program, our report. It's our gift to you, to our community, and to our ohana. It is, I just have to pat our team, our volunteers. We did an incredible job highlighting some of the most important and interesting findings into a format that's easy to digest. And it's hot off the press. It just was published earlier this year. And I selected a few pieces to share from our report of our most recent data, but you can learn even more about your favorite leeward beach by reading it for yourself. And in closing, look at this gorgeous shot of Thousand Peaks, Olowalu, Kamehameha area from one of our QA officers, Kelly James. Most of the aerial drone shots that you saw in this presentation were from her. She's very smart with her numbers, and she's also very skilled with her drone. And this is what we're working toward, using our data to make progress Mauka and have more gorgeous, clear days like this. So mahalo nui loa for sticking with us through all of that. And I now want to welcome our partner from the Nature Conservancy and Huioka Viola's lead scientist, Dr. Kim Felinsky. She'll turn on her screen in just a moment. And as I mentioned, she's been a part of Huioka Viola since the formation of it 10 years ago. We are so lucky to have Kim and her big scientific brain on our team and have her here with us tonight. And I saw you pop on, Kailea. I'm not sure if you wanted to say anything as we transition.
Hello, everybody.
Kim's here.
No, I was gonna say thank you so much. I've dove into the report myself and just such, having so much data, it's really awesome to be able to start to see those like patterns. I mean, having a decade of data is quite a feat. And like you said, like you guys have such an amazing group of volunteers and just seeing the community come together to be able to protect something that we all love. So it was so great to hear.
Yeah,
Um,
yeah.
Anything else you guys wanted to cover before moving into Q&A?
I think I'll just ask, should I stop sharing my screen and
Yeah,
just
feel
face it up?
free.
Okay,
We
I'll
have
stop.
some
Well, actually, you know what? I'll leave it up. This picture is pretty, and we might have things we might want to scoot back to depending on questions.
perfect. Awesome. All right. Well, we have a couple questions here. The first one is, do programs like the Hui exist on other islands?
I can try to take an answer to that. You guys can hear me. It looks like it. Um, yes. So we're proud to have the Hui expand this year to Molokai, and we didn't present on Molokai data because it's a little new. So it's only been happening since January, and we're still trying to analyze it and grab the trends. But we do have our first sites on Molokai chosen. And in the past, this team has still worked on Lanai, so that's Maui Nui. The sisters to this project are on the Big Island with Hawaii Viola, which samples in Keaukaha, Kahaluu, Puoko area, Kohala area. And then on Kauai and Oahu, Surfrider has played a really big role in motivating community-based sampling. There's new programs spouting up on Kauai right now that have a more Huioka Viola feel as well.
Um,
Yeah, what is there's Kauai also has, are they the coral guardians, I
Reef
believe.
Guardians, yep.
Reef
So
guardians.
Reef
Yeah,
Guardians has just
thank
finished their
you.
quality assured documents that are similar to ours. and have just expanded to Kapa'a if you're interested in Kauai. I could answer more questions later about that.
Yeah, we're very excited to see them, yeah, getting their groove. Nice question.
Talking, kind of going back to the data that we're seeing on a few of the beaches where turbidity has actually been decreasing, what are some of the factors contributing to the decrease? Could we learn how to improve turbidity at other beaches from these few examples?
It's such a beautiful idea on this, and I really appreciate this question. I think the examples that we do have are few and far between, so it's hard to really draw generalizations. But the one that stands out the most is Kahana on the west side. And Kahana has a reservoir behind it. It's one of the largest watersheds in West Maui. And that reservoir, for years when it was first built, got run over immediately by a landslide that happened and filled the reservoir to the top, meaning that it was no longer able to hold sediment. And through work of partners, we were able to dig that out. And once we dug it out, we can see that storm pulses are decreasing. So that is one bright spot that you can see and learn from. If you maintain your spaces, then you can eventually see increases and decreases in turbidity. And Tova Calendar has led the charge on that for years and years and years.
And kind of on that piece, someone is asking about how do deer affect turbidity? We're on the topic.
Deer are some of the biggest drivers, and I would say that the combination of heavy deer population and drought can really increase the amount of erosion. Plants hold the soil down, and if you eat all the plants, then you start to have big erosions downstream. So yeah, our Maui's deer problem really is pretty a direct reflection into some of the worst turbidity problems.
Makes sense. And since I'm kind of grouping them together, there's another one kind of talking about high turbidity. Could you speak to, any projects or actions that are taking place to address some of these high turbidity hot spots, like Waipualani Park, for example?
I want to make sure Tova's not here because she would speak to the Waipualani case best. But there are concerted multi-partner efforts right now happening, partnerships that are with both the county, nonprofits, and funded by bigger agencies to try to both create basin spaces to protect land that's being used as wetlands. Kealia is a great example of a wetland that can really protect the reef next to it. So making more wetland spaces, creating basins to catch the sediment like at Kahana, and then reducing those stressors above. So reducing the deer populations and making sure to keep soil on the land is the strategy right now. But it is alarming, the really serious increase that we've seen there. It really is a dramatic shift from the previous turbidity in that place. So it's something to watch and fix quickly.
Liz, I saw you go off mute. I wasn't sure if there's anything you wanted to add.
No, not quite. I mean, there's a lot to talk about with all of these things, but yeah, and I feel like I'm trying in the background to pull up some other time series and but anyway, it's a little tricky right now. So if we're not answering all of the questions as some of these things, like we could get some info from Toba on things that are happening in North Kihei, turbidity, because there's a lot of momentum to make change. And even just yesterday, as I was driving to our South Maui lab, I saw, I believe it was county workers with a big tractor scooper just pulling out some of the sediment, knowing that we were going to be getting more rain yesterday. So, I mean, I know that there are dump trucks of sediment that have been removed. There's to try to prevent it from flushing into the water. Yeah, that was one of the things I was thinking of. And also, as Kim was talking about the Kahana Basin and sediment, it is really amazing what she was saying that our data helped funding to be able to keep the basin working, help it get repaired so it can function. And you just see the trend line start to just dip right afterwards. I believe that was 2019 that happened. And you just see this trend that's like really, really high to suddenly so much lower. So these things really work, and we just need to establish more of them and keep them functional. We're just in a new era of, this, how much sediment's coming in has changed. So we just need to work harder, plan more.
Yeah, and I know there are projects like for us at Maui Nui Marine Resource Council around like deer fencing.
Oh, yes.
Another question was just actions being done to help reduce the deer population. I know deer fencing is one to kind of restore some of those waterways that do go directly down into South Maui to let the vegetation regrow and have
Mhm.
less like open soil. And
Right.
then the fences as well are something that help corral the deer into an area and hunters have an
Yeah.
easier access to
Yeah.
them.
Yeah, I've heard that's really made a difference. It's the fencing also helps a bit to prevent different herds from mating with making more babies and yeah, keep them in a little more contained as best we can. And as Kim mentioned, they just eat and eat and eat. They don't have any predators except for us to keep them in check. So they just have exploded on not our just our island, on other islands as well. And yeah, they're they munch away, expose the soil, bringing in, if other things grow in, it's definitely not native plants, and their cute little hooves kick up the dry soil that's around, and it just accumulates in the gulches. We get those flashes of rains, and it just brings more sediment than ever.
A question I love looking kind of at a positive note. What are some of the reasons to be hopeful about our nearshore ocean water quality?
Oh,
Go
do you
ahead,
want?
Liz.
Yeah, you.
Yeah.
No, you.
Um, Mine's so technical because I'm in the weeds, guys. But my personal reason to be hopeful is that when we open up new funding sources like the green fee and we invest in our malco management, right? So there's like miles of fence going in to try to keep deer out of the most important gulches above Ukumehame. That really offers the potential for those areas to bounce back mostly on their own, right? So I do see a bigger investment these days, and the importance of it is becoming more and more clear. So I'm pretty excited to see that investment take to really to protect our upper mountain areas. So that's my reason.
That's good. Yeah, I'll add in that um, I'm hopeful because we have this data. I feel like there are so many communities, island communities around the world that don't have the numbers and the data to show and to be able to identify issues. Um, Without this data, we would just be blindly saying, I want to protect the ocean and I want to protect coastal water quality. But not only do we have this data, but we have these incredible minds, Kim, other volunteers that are part of our tech team that help us collect data, Tova, Rebecca, um, and they really put their energy and efforts into figuring out what's going on. And then not only that, but we have people that are invested in us and care about the data. We're invited to county council meetings to share what we know so that better decisions are made. And we all know that things can move slowly on Maui. We have our island time, but nonetheless, it's happening, and we have the data to make impact and to answer questions so that informed decisions can be made. It's a really big deal, and it's a really big deal when we're invited into, wastewater discussions with the county, or we have the stormwater conference next month, and we have this unbiased data to show and do something with. And so I like to think that in another 10 years, we'll have even more data, we'll have even more understanding, and we'll have even more progress. I feel just very lucky to be a part of this group and all of the people that are a part of it that all just come together with the mission to make a difference. So that excites me that we have a chance. There's hope.
There is hope. And I think just seeing your guys' community of volunteers, even everyone who joined today, just that there is investment from the community into looking into these issues and understanding what's going on and hopefully pushing through some of the solutions that we need to make sure that we preserve all of our beautiful waters. Um, but I think it's a good kind of sentiment to wrap everything up on. I think it's easy to look at like, oh gosh, the doom and gloom, but there is hope. And looking at the community and each one of you, like I said, that joined, as well as um, our lovely Huyo Ola team, who is out there on the front lines every day. So thank you everyone for joining. Like we have said, we please take a look at the report. There's a lot more in there, which we could get into, of course, but a labor of love that really looks at each and every piece. So, um, on our side, as I mentioned before, we do have an upcoming one, but please sign up for our newsletter. We will have more talks like this coming towards the end of the year. Um, oh, yes, of course, mahalo to all the organizations. And then join us on October 13th. We will have our next speaker series with Thomas Oliver, who is a PhD research ecologist at NOAA, to be talking about the rising water temperatures due to El Nino and what, threats that really poses to Hawaii coral reefs. By that point, we will have kind of been in the heart of the heat that will be happening. So we'll have some data to talk about there. But for reminders, please sign up for the newsletter, just so we can get that out to everyone. But again, thank you, everyone. Thank you for joining tonight, and a hui ho. Mahalo.
Mahalo.
Bye, everybody.